All right, here is lesson 5 of module 5. We are on the back of the problem set number 4, and it says to determine the area. So I know area is the space inside that we cover with squares. Of the shaded isosceles, and the word isosceles just means that it has two equal sides. So this is an isosceles trapezoid because these two sides are exactly the same. So isosceles triangle has two legs that are exactly the same, and isosceles trapezoid has two legs that are the same. And it says the image is not drawn to scale. So we have a couple of options that we could do when we are solving this trapezoid. We could use the trapezoid formula, which again, if I'm looking at my math notebook, I could write right here, area of a trapezoid. We could use that formula, and it's color-coded, so you should be able to see where the different parts come from that shape if you look at the resource in your math notebook. There is a drawing of and color coding of what the bases are and the heights there. Or another option would be to find the area of the large rectangle here and then subtract these two triangles. Excuse me, somebody needs some water. So, if I were going, for me, I think the easiest would be to use the trapezoid formula. But if I was going to use this one for the triangles, one of the things we want to do is figure out these different lengths. So I know that the triangle, or in this case, the big rectangle would be 18, because that's what that one is, by 12, because those are the lengths and the width of this big rectangle here. So I could find the area of that rectangle first, using again my resource in my math notebook that tells me what the formula is for rectangles. And then I will need to find the area of these triangles. So I would look in my math notebook, I would find that what the formula is for the area of a triangle. And I know that I need to have these two legs here because this would be the height of my triangle and this would be the base of my triangle. So we have a base and a height here. Well, I know that the height would be 12 because these are opposite from each other, so those are both 12. But how do I find the base right here? Well, this is where we use 18, so we know this whole thing has to be 18. If this part is 3, so running out of colors here. This 3 is meaning this part right here. So we have 3, and then we have 2 pieces here that need to add up to 18. So I know I'm here at 3, but, so 3 plus what number would give me those? So I'm thinking, okay, the whole thing has to be 18. So minus these 3, that means I have 15 left over to split between these two pieces. So on my calculator, I would do 15 divided by 2, and that tells me that each of these would then be 7.5. Because 7.5 plus 3 plus 7.5 would give me that 18 that is this whole entire thing here. So if I know that this is 7.5 and I know that this is 12, I can now utilize my formula for triangles and find the area of this. And so I could do the area of the entire rectangle, whatever that is, minus the area of the triangles. And that would give me the area of the trapezoid. So it's your choice which way you do it. You can either do the area of the trapezoid formula up here, or you can do the entire rectangle, find that area, find the area of each of these triangles, and subtract that from the large rectangle, because we don't need those pieces. We don't need to cover those in squares, so we could subtract that out. Next, let's go to this one here. So here it says, here's a sketch of a wall that needs to be painted. So I see I have a big wall, I have windows, and a door. It says the windows and door will not be painted. Calculate the area of the wall that will be painted. So these pieces here do not need to be painted. So I need to take those out of my equation. So the first thing I need to do is find the area of the entire wall. So I would do the area of the big rectangle. You should be able to do that very easily. Then I need to find the area of the windows. Again, that should be a pretty easy calculation for you. And then I need to find the area of the door. So once I have the big rectangle, that's the whole thing. If I don't need these windows and this door, what operation would I do to get rid of those pieces? So that's what you need to ask yourself in order to find in the end what part will be painted. So again, the big rectangle is this big part here, this wall. Look for those measurements that you could use there. These windows, find the area here and here. Then, and so I would put 2 spaces there, or you could double it. And then the area of this rectangle here, find the dimensions, and what we do, you can use your calculator, and then think, how can I get rid of these spaces from my overall area that I had found in the beginning? Then part B says, if a quart of extra thick gooey sparkle paint covers 30 feet squared, how many quarts must be purchased for the paint job? So that tells me that I need to look at my amount that needs to be painted, which would be my answer that I found there, and then I need to break it into how many 30 feet pieces are in there, how many 30 feet squares are in that piece. So that tells me that I probably need to take my painted area, which is my calculation from here, and then I need to divide it into how many 30 feet squared sections do I have, and that will tell me how many quarts I need to buy. And you also think about, if it doesn't come out exactly even, does that mean you have to buy an entire another quart, or does it mean you don't need that quart? So you have to think through that context there if you have an extra piece or a decimal or a part of a quart that you need to be able to cover. Okay. Number 6 says the figure below shows a floor plan of a new apartment. New carpeting has been ordered, which will cover the living room and bedroom. So we're covering this and this, but not the kitchen or bathroom. So we're not covering the kitchen or the bath. Determine the carpeted area by composing or decomposing, means putting together or taking apart in 2 different ways. So that tells me they want me to be flexible in my learning here. So it's already decomposed into 2 pieces here. One way would be to find the area of the bedroom and the area of the living room. And then you need to think about, what would you do with the fact that you need carpet here and carpet here? What operation would help you to find the amount that would be total for all of them? That's method 1. For method 2, what else could we do here? Well, I remember up here in this one, we found an area and then subtracted things out from it. So I wonder if I could do that down here. Could I find the area of the entire floor plan of the apartment and then subtract out the pieces that I don't need, would that leave me with just the area that I do need? So that's an option for a method 2, is find the area of the whole apartment, and then find the area of the bath and the area of the kitchen. And since I don't need those, think about what operation you need to do to the total in order to find just the pieces that are left. So hopefully you can figure that out. All right, we will see you tomorrow.